Hello students, Mr. Courtney here. In this video, I'm going to be talking about concentration, that is expressing the concentration of a solution in different units. We've talked about expressing concentration as molarity, which is the number of moles of solute in a given amount of solution, where the volume of the solution is measured in liters. Today we're going to talk about measuring by percent mass, mole fraction, or molality. So we start with percent mass. Percent mass, basically we're going to do grams of solute over the grams of solution times 100. So that is how many grams of the solute we have in the total grams of solution. And to get the grams of solution, we're going to add the mass of the solute and the solvent. So let's look at an example. We have 25.0 grams of sugar dissolved in 165 grams of water. Calculate the percentage composition or concentration. So you first know that this is the equation we're going to be using. We need grams of solute and we need grams of solution. We can calculate our grams of solution by adding the two masses of our solution of solute and solvent together. So we have 25.0 grams of sugar plus 165 grams of water. So we add these together to get our grams of solution. Since we want percent mass, we take the grams of solute, which is 25.0 grams, divide by 190, multiply by 100, and that will give us our percent mass. And our answer requires three significant figures, so we get 13.2%. The second one is the mole fraction. Mole fraction is the moles of A, which is the moles of the substance whatever substance we want. So moles of a given solute divided by the total number of moles. So that means we must find the total number of moles. We have to find moles of the solute and moles of the solvent, add those together, and that will give us a total number of moles. Okay. Example. So if the molar mass of sugar used in the first example is 342.3 grams per mole, so we're given the molar mass of it, we're given the molar mass of sugar, and we want the mole fraction of sugar and the mole fraction of water. So to calculate mole fraction, we need to know, for sugar, we need to know moles of sugar, total number of moles. For mole fraction of water, we need to know moles of water divided by total number of moles. So to find our moles of sugar, we take our 25.0 grams and divide it by its molar mass. So that gives us the number of moles. So here we have our number of moles of sugar. We do the same thing for water, and we calculate our number of moles. So we have our individual number of moles. Now we need to find our total number of moles. We're going to add these two number of moles together. Now that we have the total number of moles and the individual number of moles, we can do a mole fraction of sugar. So which is 0.07304 divided by 9.232. So we get 0.00791. And we do the same thing for our mole fraction of water. We get 9.159 divided by 9.232. We get 0.992. Now something we should always note. In mole fractions are all, since it's out of a fraction, they're always going to add to a whole. So they will add to give us 1. Molality. Now molality may sound like molarity, but it's not. Molality and molarity are similar in the sense that they both use moles of solute. Molality uses kilograms of solvent, so moles of solute in a kilogram of solvent, whereas molarity uses moles of solute in 1 liter of solution. So that's our distinct difference. So we're asked here to calculate the molality of the solution in example 1. So we know that we're using this equation, moles of solute over kilograms of solvent. We've already calculated the number of moles of solute. Now we need to get our kilograms of solvent. So we take our grams given, divided by 100 grams. So we know that we have 100 grams per kilogram. That'll give us 0.165. So now we have everything. We have our number of moles and we have our kilograms of solvent. So now we can go ahead and calculate all our molality. The number of moles divided by kilograms of solvent, we get 0.442 moles per kilogram, or you may see in some cases that we put a lowercase m. I should have put that also. Let's look at some examples that require some additional steps. Same principle, but you have to think a little bit different. Now, how many grams of 3% saline solution must be measured out to get 0.25 grams of solute? So let's see what we're given in the question. We're given the percent concentration by mass, and we're given how many grams of solute we want. What we don't have is the grams of solution. So we know the equation we're going to use, percent mass, is the grams of solute divided by grams of solution times 100. We have this, we have this, we do not have this. That means we have to solve for grams of solution. So this is our percentage, 3.0, our grams of solute and our grams of solution. So now we're going to just transpose to get our grams of solution. It's 0.25 grams divided by 3.0 times 100, and that will give us 8.3 grams of solution. So all we did here is that we took the equation, look at what was given to us, and then solve for the unknown. So we have our grams of solute or percentage. We don't have grams of solution. We transpose the equation to solve for our grams of solution. We get 8.3 grams. All right, so let's look at the final example here. So we're asked, so how many grams of methanol must be dissolved in 250.0 milliliters of water to produce a 3.25 molal solution? So we're given 250 milliliters of water, and we're also given the molality of the solution. So if we're dealing with molality, we know that we're going to have moles of solute per kilogram of solvent. But we don't have kilograms, we don't even have grams of solvent. So we first need to look at how do we convert our 250 milliliters into grams or kilograms. We have to use that the relationship or the density of water, where the density of water is 1 gram per milliliter, meaning that 1 gram of water has a volume of 1 milliliter, or 1 milliliter of water has a mass of 1 gram. With that said, that means we have 250.0 grams. Then we convert our 250 grams of water into kilograms by dividing by 1,000. Now that we have that, we can substitute into our equation. Because we know the molality already. This is our molality. We now have our kilograms of solvent. We can substitute that into the molality equation. So we have our molality. We don't know moles of solute, but we know how many kilograms of solute we have. So that gives us 0.08125 moles. But we were not asked for moles. We were asked for grams. So that means we have to convert our moles of solute into grams of solute. And remember, to convert moles to grams, you have to multiply by the formula mass of the substance. So we take the 0.08125 moles and we multiply it by formula mass of the solute, which is 32.04. And that gives us an answer of 2.60 grams of methanol. So here again, we made use of our equation. We substituted our unknowns into the equation and then solved for the unknown. All right, that takes us to the end of this video expressing concentration in different units. Until the next time, I'm out. Blessings.